Hello. Today I'm going to talk about chapter 13. Okay, chapter 13. This chapter is quite technical, the way that it requires a lot of calculations. Okay, so I'm going to be taking my time. So this video may be long, but I'm going to taking my time to walk through these steps so that you can understand how to do the calculations. Okay, so the outline. So I will first talk about the expected returns and the variance. Okay. In chapter 12, we have learned about the returns and the variance, right? So in this chapter 13, we're going to learn the expected returns and the variance. So we're going to talk about what does that mean. And you must have heard about the portfolios, right? When you are making an investment, you are having different types of investment, different types of assets, like into a portfolio, right? You don't just put all eggs in one basket, right? You don't put all your monies into just one investment, but you put like multiple assets, right? Try to diversify. So that's called a portfolio. It's a basket of different investments. And then I'm going to talk about how the announcements, right, on the information announcements and the surprises and the expected, that would expect the return. I'm going to talk about the risk, the systematic, unsystematic risk. So there are two different types of risks, systematic and unsystematic risks. Okay. And diversification and portfolio risk, and how the coefficient of beta is related to systematic risk. 哎，你们别说话行吗？你们不要说话，我在录音录课呢。Okay, now let's keep talking about the first one, the expected returns. So what are the expected returns? So we are living in a world that with uncertainty, right? So often an event can turn out into different possible outcomes, right? So, and then there are different possibilities, right? So if you have a coin, right? If you're a coin, you flip a coin, right? So then you could either get a head or tail, right? Those are the possible outcomes, right? When you flip a coin, the possible outcomes are either head or tail, right? And then what are the probabilities? You don't get both, right? You flip a coin, you can't get both head and tail at the same time, right? So there are the possible outcomes, right? Only one of the outcomes will be the result. And what's the possibility for each outcome? Well, you know that 50% for head and 50% for the tail, right? So, but if you throw a dice, right? The dice has 6 forces, right? So numbered with 1, 2, 3, 4, 5, 6, right? If you throw a dice, right? There are 6 possible outcomes, right? From number 1, number 2, number 6, right? And so what's the possibility for each outcome to show up, right? So the numbers, each number has the equal probability to show up, right? So it will be 1/6, right? Possibility. So when you are doing an investment, right? How much money you can make, right? You could have the best scenario, you make, let's say, 100% return. And you could have a mediocre scenario, you make 30%. And then you could have a worse scenario, you make a negative 20%, right? So those are the, let's say, the 3 possible scenarios, possible outcomes. And then you're going to evaluate what's the probability of that outcome to happen, right? So therefore, you combine all these situations, you are using the probability, okay? So then you can calculate what's your expected return. So the expected return equals the outcome result and then multiply the possibilities. Okay. So for example, if I'm gambling, okay, if I'm gambling with another person by flipping the coin, right? If it's head, I'm making $100. Okay, I'm going to write this down. Okay, just give me 1 second. Let's see. I'm gonna draw. No, sorry. So where is it? Okay, so where is my tool? Sorry. Where's my tool? Okay, right here. Okay, got it. Oh, no. Weird. Where is it? Okay, anyways, I'm gonna use this. Okay, I'm going to use this. So I can. Okay, good. So so if you flip the coin, well, you have 50% chance it's to be head, right? Let's say if it's head, I'm gonna win $50. Okay. And then if it's tail, and it's also 50% chance, I'm gonna lose $50, right? So when I'm playing this game, how much money am I expected to earn if I keep playing this game, right? Let's say I playing this game 1,000,000 times, right? So what is the expected earning for me, right? What is the expected return? Well, so you have 50% chance, 50% times $50, right? You earn $50. You also have 50% chance to lose $50. That's a negative 50. So if you keep playing this, right, over time, actually your expected return should be 0. Okay, so you have equal chance of losing and winning for the same amount of money. And if you playing this many times, you are expected to just, to be 0. You don't make any money or don't lose any money, right? So that is this, right? So this is my probability, and this is my return, right? So P1 is 50, and R1 is $50. P2 is 50, and R2 is as negative 50. So in this case, I only have two scenarios. So n equals 2. Okay. All right, let's move on for some other examples. Okay, sorry. Okay. Okay, good. Okay, I need to get rid of this. Sorry. Clear all the drawings. Okay. Okay, so in this case, suppose you have predicted the following returns for stocks C in the 3 possible states. Okay, there are 3 possible states. What are the expected returns? Okay, so the states are boom, right? This is a good condition. So the probability for that is 30%. And you're gonna have a return of 15%. Okay, if it's normal, the probability is 50%. Okay, and then your return will be 10%. If it's a recession, that's the very bad situation. Okay, and then you're gonna have let's see, you're gonna have this 2%, right? So that's the worst scenario. So now the question is, do you know what is the probability for the recession to happen? Okay, you know the probability for boom is 30%, normal is 50%. So what's the probability for recession? Right? Well, you know the total probability should be 100%, right? It should be 1, okay? Because it has to be one of the 3, right? So one of the 3 has to happen. So together the probability is 1. So now I use 1 minus 0.5 minus 0.3. So that will be my 0.2. So I know that I can calculate the probability for recession is 20%. Okay, so now let's calculate the expected return, right? So what is my expected return? So when we use the symbol, we often use the capital letter E. So that's kind of stands for expected, right? So expected return ER would equals, so it's a sum of the different scenarios, 1 to n. Suppose there's n scenarios, and for each scenarios there is the probability, and then there is the outcome, right? There's the outcome return. So in this case, I have 3, right? I have P boom times R boom, and plus P normal times R normal, and plus P recession times R recession, right? So that's the sum, right? This symbol is the sum, like a M, like M, the letter M fall down, right? Like, so that's kind of representing the sum. So I have n equals 3 because I have these 3 different states, right? So then when I do this calculation, so PB 0.3 times return 0.15 plus 0.5 PN times RN 0.1 and plus 0.2 times 0.02. Okay. So these are the weight, right? These are the weight. If I use a different color, can I use a different color? So those are the weight, right? Those are the weight. So that's where this is. So this is weight, right? And then these are the return, the outcome, right? These are the outcome. So if you do this calculation, so this one will be 0.045. This one would be 0.05. And this one would be 0.004, right? So together, I should get 0.099, okay, 0.099. So my expected return in this situation would be close to 10%, right? So 0.099. So this is how you calculate the expected return, okay? So when you do the one thing you want to be careful is that this one, the 3 returns, they won't happen all at the same time. Only one of them will actually happen, right? Only one of them will actually happen. Okay, so now let's move on. Okay, so I get the expected return of C, stock C, is 9.9%, okay? And now, in terms of variance and the standard deviation, okay? For variance and standard deviation, if you remember, when we have actual observations, okay, so we have, let's say, just give me 1 second. When we have actual observations, right? Let's say you have actual observations, you have n, right? Okay. And so what you do to calculate the mean, right? The mean would be, you calculate the mean equals x1 plus x2, right? Plus and plus xn, and then you divide it by n, right? Okay, this is called mean. So the difference between expected return versus mean is that if you calculate the mean, each of this number, they are the actual result. Okay, when you do the statistics, right, stats, when you calculate mean, each of this observation, they are the actual result. Okay. But when you talk about the expected return, right? Those expected return for each of the number, they are the possible, right? Possible result, not the actual result. And in fact, only one of those results will actually happen, right? So make sure you know that difference. And then when we calculate the deviation, right, the variance, when we calculate the variance in the stats, right, the way we do it is this mean is x bar, right? We are going like, okay, so we do a sum, right? You know, I from 1 to n, right? And then you go xi minus x bar, so that's the average, and the square, right? And then you divide it by n minus 1, right? So you take the sum of the square, the difference, divided by n minus 1. So that is your variance. And then your standard deviation, SD, is just the square root of the variance, right? So that's how we calculate the variance and standard deviation when we are in the stats course, right? Note that each of these xi, x1, x2 through xn, they are the actual result, not the possible outcome, okay? But here we are dealing with the expected situations, right? So the observations, they are just possible observations. They're not actual observations. So in those cases, when we calculate the variance, we don't use the n minus 1, okay? Because there's no n observations, right? Instead, we use a similar equation, but we consider the probability for each of the possible outcome, okay? So you can compare the formula here is very similar to the variation calculations in the stats course. But in this case, the outcomes are not all actual outcome. They are possible outcomes. So there's a probability for each outcomes, right? So when you do this square, you do the square of the difference, you have to use the weight of the probability of the possible outcome, okay? So don't be confused. Some students got confused with this formula versus this one, okay? They are very two different things, okay? Okay, so now let's calculate the variance and the standard deviation of the stock C, okay? So we have done this part, right? We have done this part. So we know the probability, we know the return. So we calculate the expected return to be 9.9%. So now let's keep going to calculate the variance, okay? So to calculate variance, so you take the outcome. So for example, the boom, the possible outcome is 0.15. So use that minus the average expected return. So that's the 9.9%. And that difference you square, and then you apply a probability. And the probability for the 0.15 is 0.3. So 0.3 times the difference square, okay? So that's just one state. So then you keep doing this for the other state. For the normal, so the probability is 0.5 here, and then the return is 0.1. And the next one, the probability is 0.2, and the return is 0.02. So then you add them up, you get this result to be your standard, to be your variance. And then you take the square root of this number, you get the standard deviation to be 0.045, okay? 0.045. So I hope this makes sense, okay? So what are the portfolios, right? Basically, portfolio is a collection of assets, right? Asset. So if you think about library is a collection of books, right? The portfolio is a collection of different investment assets, okay? For each individual asset, the risks and the return, right? So when you think about the risk, right, for investment, the standard deviation, right, that really measures the risk. The return would be the expected return, right? So these are important because each single individual asset in the portfolio, their returns and risk is going to affect the overall risk and return of the portfolio. Okay. So what about the portfolio, the risk and the return? So when you are not seeing each individual asset in the portfolio. When you consider this portfolio together as one, what is the return and what is the risk? So that is measured. Okay, that is measured by the portfolio's expected return and the portfolio's standard deviation, right? So how to do that? Well, the similar way to do with the individual assets, right? You use a similar formula to calculate the portfolio attributes, their return, their standard deviation. So I'll give you one example. So suppose you have $15,000 to invest. You have purchased securities in the following amount. What are your portfolio weights in each security? Okay, so in this portfolio, there are 4 securities, right? And you allocate the $15,000 differently into different stocks, right? Different security. So depending on the dollar amount, you are able to calculate how heavily weighted of the security to the portfolio, right? So obviously, JKL, you allocate $6,000 out of the 15,000. So there are more weights on this stock security in your portfolio. So when I do the calculation, I use the dollar amount assigned to each security divided by the total dollar investment. So I'm able to calculate the weight, okay, assigned a weight of each security in the portfolio. The expected return of a portfolio is the weighted average of expected return for each asset in the portfolio. Okay, so this J representing, so the P means portfolio, right? So RP is the return of the portfolio. E means expected. So E bracket RP, this represent expected, okay, return of the portfolio. Okay, so that equals J from 1 to M. So J representing here is the each security, right? Each individual asset. There are M assets in this portfolio. J equals 1 to M. Okay, and then for each asset, there's different weight. So that's WJ, right? WJ representing the weight on that individual asset in the portfolio. And E, of course, here is expected, and R return J. So this is expected return of the asset J, right? And then you apply by their weight. So you sum them together, that give you the expected return of the whole portfolio. You can also find the expected return by finding portfolio return in each possible state and computing the expected value as we did with individual securities. So again, we are still calculating expected return of the portfolio, but we can use a different way, right? So we have talked about this formula. So this is one way. Another way is the state, okay, the state. So in this scenario, we are saying, well, there are n state, k equals 1 to n, right? That means there are n possible outcomes for the portfolio, right? You have n states, so there are going to be n possible outcomes for the portfolio, and then there are different probability for each states, right? So I use SK here representing the probability for each different state, and then multiplied by the expected portfolio return of each state, and then you add them together. That would be your expected return of the portfolio. So there are two different ways to calculate, right? To calculate this. So this equation is you first calculate the each individual asset's expected return, and then you use the weighted average. Okay. The second one is you calculated the portfolio's expected return for each state, and then you put the weight of the states to calculate the expected return for the portfolio. Okay, so in this question, consider the portfolio, the weights we have already computed, right? So this one, these 4 securities, we have calculated the weight, and they have a return. So the weight are in the red color, okay? This in the red color, they're representing the weight of each security in the portfolio, and the return is given. So we can use the formula. So we can calculate expected portfolio return is the weight of that security ABC times the return of ABC. Okay, and then 0.2, that's the weight of DEF times the return of DEF, 8.96. So you add them all up, expected return of the portfolio is 10.24%. Okay, so that's how you calculate the expected return of a portfolio. Portfolio variance, okay? So you can compute the portfolio return for each state. We have talked about that already. So when you compute the portfolio variance and the standard deviation, you use a similar formula as you use for the individual asset. So you can just treat that the portfolio as an individual asset, right? Just treat it as one individual asset. You're going to use the same formula. Okay, let's take a look at this question. Consider the following. So you are investing the 2 securities. One is A, the other one is B. And then the weight is you invest 60% of your money. So 60% of A, 40% of B. And there are 2 different economic states, boom versus bust. So for boom and bust, they are equally likely to happen. So each have 50% chance. The result you can see are quite interesting. Stock A is doing well when it's booming. Economy is booming, say 70%, but doing very bad, negative 20% when it's bust. But stock B is the different. When it's booming state, it's only 10%, while it's bust state, it's 30%. Okay, so let's take a look. The first question is, what is the expected return and the standard deviation for each asset? So before we consider the portfolio, let's look at each asset. What is the expected return? What's the standard deviation? Okay, and second, we want to calculate, taking A and B, the portfolio together, what is the expected return of that portfolio? Okay, and what is the standard deviation for that portfolio? So let's answer the first question. What is the expected return and the standard deviation for each asset? Okay, we're going to do A first, right? Let's go into do A. So, so for A, the expected return, there are 2 possible outcomes, 70% and negative 20%, and with equal probability, 0.5, 0.5. So what's the expected return? So you use 70%. Okay, so that's the boom state, and the possibility is 0.5. So 0.5 times 70% plus 0.5 times negative 20%. Okay, so that would be your expected return of A. So that result is 0.25. Okay, 0.25. Okay, so now you calculate the standard deviation. Okay, so your state boom state is 70%, and the probability is 0.5. So 0.5 times the outcome is 0.7 minus the average is the expected return minus 0.25, and you have to square it, right? And then plus the second state, negative 20%, negative 0.2 minus 0.25, that's the expected return. And then you take the square, right? And then you multiply it by the 0.5%. So my variance, when I calculate my A, so that's going to be 0.2025. And my standard deviation will take the square root of the variance. So that will be 0.45. Okay. So now I'm able to calculate my expected return for A is 25%. And my standard deviation for A is 0.45. Okay. Well, you're going to repeat this. You can do the same thing, and then you can calculate expected return of B. Okay, will be 20%. Okay, oops, will be 20%. So if you think these two numbers are equally happen, possible equal, these two results are able to happen with equal probabilities. So just take the average, 10 plus 30 divided by 2, right? So that's the 20%. And then you're going to use the variance, use 0.1 minus the average, 0.2 square, and give the probability of 0.5. And now the second state is 0.3 and minus the 0.2, which is the expected return, take the square, and times the probability. So you get 0.01, and the standard deviation is the square root of the 0.01, so that's the 0.1. Okay, so now I got my, for my A stock, so the expected return is 0.25, standard deviation is 0.45, and for B, stock B, the expected return is 20%, 0.2, standard deviation is 0.1. Okay, so if I, just give me a second, if I write this down, so this one look like, if you are saying that would be the standard deviation and expected return. So for A, so that's going to be 0.45 standard deviation and return 0.25. Right? For B, my standard deviation is 0.1. And my return is expected return is 0.2. Okay, so it's really important when you are able to calculate these numbers, right? Because the first number, this is standard deviation. This measures the risk, right? The higher the standard deviation, the higher the risk, right? So these are the risk. The first number is risk. And the second number, the expected return, this would be your return, right? So for any investment, you should be able to calculate these two numbers. One is the standard deviation. The other one is the return, expected return. So that's the risk and the return, right? So we're going to use these two numbers later on in a graph, okay? Okay, so we have done the first question. We calculated the expected return and the standard deviation for each of the individual assets. So now we want to answer the second question. What is the expected return and the standard deviation for the portfolio? So now let's not see each individual asset one by one. Let's take A and B together, okay? Well, you have already calculated for A, the return is 25%. You need to apply the weight. The weight is 60%. Plus, for the B, for the second stock, your expected return is 20%, but the weight is 40%. So now you calculate the expected return of the portfolio is going to be between 0.25 and 0.2 and 0.25, right? So if you only invest in B, you get 20%. If you only invest in A, you get 25%, right? When you are allocating your money, you're gonna achieve an expected return between 20 and 25%. And in my calculation, once I apply the weights, I calculate the expected return is 23%. Okay. So now let's calculate the variance, right? So I'm gonna use the situation to use the portfolio to calculate the variance, right? So I want to calculate the return for each state. So let's take a look at the boom state, right? When it's booming, how much the portfolio will earn, right? Well, when it's booming, A will earn 70%, B will earn 10%, right? But you are considering a portfolio, so you have to consider weight. So 60%, 0.6 times 70% plus 0.4 times 0.1%. So 60% of money is going to earn 70%, and the 40% of the money is going to earn 10%, right? So together, you are expected to have a return of 46%. So if when the economy is booming, the portfolio is going to yield a 0.46%. I'm sorry, 0.46 return. Similar idea, when the economy is busting, you're going to use the return negative 20% and the 30%. So 60% of the money you're going to earn negative 20%, and the 40% of the money you're going to earn 30%. So when you do this calculation, the expected return, so the portfolio return when the economy is busting will be 0. Okay, so you have two states. When the economy is booming, your portfolio return will be 0.46. When economy is busting, your portfolio return is 0. And what is expected, right? Because the probability for each state is 50%, so the expected return on the portfolio is the between. So 0.46 minus 0 divided by 2, so that's 0.23, right? We already calculated that. So now let's do the variance calculation of the portfolio. So I do the first state. I have 50% times boom state. The result outcome is 0.46 minus the expected 0.23 square plus the bust, also 50% chance times the outcome, expected outcome is 0 minus the expected return of the portfolio, 0.23 square. So I get 0.0529. And standard deviation will take the square root of the number. So I get 0.23, sorry, 0.23. So my expected return would be, my expected return on the portfolio is 0.23. My standard deviation for the portfolio is 0.23. So 20% return, and the risk is 0.23. So this is one way you can measure the portfolio expected return and the standard deviation. So I have another way to calculate this, right? Another way to calculate this. So again, expected portfolio return is the same, right? For calculating variance, I have a different way. So when you are calculating variance of portfolio, you could also first calculate the variance of each individual asset and their covariance. Okay, so what's the result? So the portfolio's variance equals the weight square of the variance of A plus the weight square for variance B, okay, and plus 2 times the weight multiplication times the covariance of A and B, okay. I trust you have learned covariance, right? You have learned the covariance So the covariance equals, so that would be the cross multiplication, right? So you have the state 0.25, that's the possible outcome, times the first one would be A, so the booming, okay? So A minus the average, and the B minus the average. Okay, so 70 minus 0.25, the average, and times B, this is A. So the green color is A, the purple color is B, right? Because we're calculating a covariance. So you have to do, instead of being square, it's a multiplication between A and B, right? Instead of A square or B square, when you're calculating the variance, when you calculate the covariance, so it's A times B, right? So A is the difference. A is the green color, and the difference B is the purple color. So and then for you have to assign the state with the probability 0.5. Okay, so I calculate the covariance to be negative 0.045. So when I calculate my variance of the portfolio, it gets the same result, 0.0429. And standard deviation is 0.23. Okay, whichever way you are comfortable with, okay, whichever way you are comfortable with, you can calculate that way, okay? You don't have to stick with only one method, okay? You have an option. I don't know how much you have learned in the stats course about covariance, right? All this stuff. This course is not a stats course, so I'm not going to go through that in the lecture because we have limited time. If you don't know those things, make sure you pick up your stats course and just to fresh your mind about how to do all these calculations, okay? But either way, right, you calculate your portfolio, return and variance in two ways, that's fine. Yeah, either way is okay. And you also have learned about correlation, right? So correlation equals, so A and B, are they correlated, right? To answer this question, correlation equals covariance divided by standard deviation of A times standard deviation of B. So in this scenario, we have calculated the standard deviation A as 0.45, B is 0.0. So when I do this calculation, I realize that the correlation is -1. Okay, so they are negatively correlated, and the correlation can only go from -1 to 1. -1 means they are negatively correlated, right? If you go to the east, I'm going to the west. You go to the north, I'm going to the south, right? You are gaining weights, I'm losing weights, right? So, so if you think about the correlation, if they are negatively correlated, like -1, so they are perfectly correlated. So they always go the opposite, okay? They probably hate each other. They always go with the opposite, okay? So in this case, you can see it is a negative correlation, -1. And then you can take a look, right? One condition, economic states condition changed from boom to bust. A performs worse. So from 70% to -20%, right? But A is performing worse. If they are negative correlated, B should go, oh, you are going down, I'm going up, right? I'm going good, right? So for B, they are going up from 10% to 30%, right? So that's what the correlation means, right? Are they going in the same direction or the opposite direction, right? So if its correlation equals 1, they always going on the same direction. They are wearing the same pants, right? They're on the same boat, right? But if correlation is -1, they always go to the opposite direction. If correlation equals 0, there's no relationship, right? They don't care each other. Doesn't matter what you are doing. Doesn't matter what you are doing. I'm doing my own way, right? Okay. So when correlation equals -1, okay, you can see that when the purple line, sorry, where is the purple line? I'm blind today. The blue line versus the green line, right? So the blue line is A, the green line is a B, right? If you take a look at this, it's interesting because when B, the green B at the peak, A is at the valley, right? Okay, so when the green line is going up, okay, so you see from this valley to this peak, B is going up, and A is from this peak to this valley going down, right? So it's interesting, right? Over the time, they always go the opposite, right? They always go the opposite. So that's the correlation -1. If you plot a graph on a 2-dimension with the x-axis, horizontal axis to be the return on A, and the return on B on the vertical axis. So when you plot it, you see this line, if they are perfectly correlated, negatively correlated. You see this line, right? So when A is going up, B is going down, right? So that's the correlation when the correlation is -1. When the correlation is equals 1, they are perfectly correlated. See, when you are at peak, I am at peak. When you are at the valley, I am also at the valley, right? So two brothers, right? Suffering together and enjoying the life together. These are the true brothers. Okay. And then when you plot it in the 2-dimension, it's a straight line with a positive slope, right? Because when A is going up, B is going up, right? When A is going up, B is going up. So when correlation is 0, you can see that they don't carry each other, right? I don't know where your peak is, where your valley is. I'm going my own way, right? The green, the B is like fluctuating, right? And all this funny, like grass type of plot. And if you plot them into 2 directions, they are not forming a line, a trend. So basically, when A is going up, B is everywhere, right? You take a look. If you move A from the left to the right, the B can be like, anywhere, right? Going B can be positive, negative, the changing up and down, right? So the idea here is they are not correlated. Okay? And now, what if they are less than perfectly correlated? What if the correlation is not 1? Let's say it's 0.7, right? So then, this is, if it's 0.7, so you can see that they are not perfectly aligned on this straight line, right? But you can see the trend. They are forming this kind of trend, right? Same idea here. This is a negative. If it's not a -1, if it's a negative 0.7, right? The slope is negative. So, and then you can see that there are kind of observations surrounding, right? Surrounding this line, forming that trend. So they are not on the line. Okay, that means they are not perfect positive or negative correlation, right? But you can see that the trend is forming that line, so they are less perfect. So they are maybe correlated, right? So there is the order, it's not like random, right? There is the order predicting a certain trend, okay? So in this case, this would be, this one, the left picture will be a correlation between 1 and 0, and the right picture would be a correlation between -1 and 0. Diversification. There are benefits to diversification whenever the correlation between 2 stocks is less than the perfect. Okay, if 2 stocks are perfectly positively correlated, then you are not diversify yourself. So basically, one is up and the other one is up. One is down, the other one is down, right? So you are not really diversifying your risk, okay? Because they are moving on the same direction, right? So if you buy 2 stocks in a portfolio, they are positively correlated, perfectly positively correlated. So you are basically just trading off the return, right? So one stock has higher risk, higher return. The other one is lower risk, lower return. When you are putting them into a portfolio, you did nothing. You just trade off, right? So making the return and the risk in the middle between the two stocks. So this picture really speaks a lot, right? Maybe this is not very easy for you to understand, but I think it's really important and it's really interesting, this picture. So I'm going to spend some time on this, okay? So you have a stock L is A, right? So I should say this is A. And you remember these two numbers. Remember when we did the calculation? The standard deviation is 0.45. The return is 0.25. So if you think about this asset A, the L, the risk is 0.45, the return is 0.25. And for B, the risk is 0.1, and the return is 0.2. So the horizontal axis representing the standard deviation, the risk. The vertical axis representing the return, okay? So that's the return. So I'm able to label, based on the risk and the return, A at the top here, right? And B at the lower and left, right? So the idea is if in my portfolio, I only have L, I'm gonna have a standard deviation of 0.45 and the return of 0.25, right? If I only have B, my standard deviation will be 0.1 and my return 0.2. So why put them into a portfolio, right? So what happened is the risk and the return has to be between the two, right? So so this set up like a bond, right? Okay, so now let's take a look at the different scenarios. So first, let's take a look at this green line. This is the perfect positively correlation. So when A and B are perfectly positively correlated, so the low equals 1, right? Equals 1. So what happened here, we start with the portfolio standard deviation. So portfolio standard deviation equals the weight square of A times A's variance. Okay, so the portfolio variance equals A weight square times A variance plus B weight square times B variance plus 2 times weight A times weight B times standard deviation A times standard deviation B times rho. So that's the formula if you still remember in the stats, right? That's the formula. And now, if it's perfectly positively correlated, your rho equals 1. So now the equation will be simplified as this, okay? Equation will be simplified as this. So I did nothing, it's just pure algebra, okay? So now I'm gonna solve the standard deviation of the portfolio. So that actually equals 0.35, the weight of A minus 0.1, okay? And I also be able to calculate my return of the expected return of the portfolio, okay? So that actually equals 0.05 times the weight of A, okay, plus 0.2. So you can see that my standard deviation of the portfolio, expected return of the portfolio, all linked to the weight, okay, the weight of A. So through this link with the two equations, I'm able to find a relationship between EP and sigma P. So that relationship is this. So EP, that's the a portfolio return, is the vertical axis, and sigma P, so that is the horizontal axis, okay? So I'm able to find out the relationship as EP equals sigma P plus 1.3 divided by 7, and you know this is a straight line, right? So that's the green line. That's the green line, the straight line here. So the equation, I use a green color representing this linear equation representing this green line. If you don't believe me, then you can test it. you know there are 2 points on this line, right? So one point is when sigma p equals 0.1, your EP should be 0.2. So if you bring sigma p as 0.1, so 0.1 plus 1.3, so that's 1.4. 1.4 divided by 7, that's 0.2, right? So you see, when sigma equals 0.1, EP equals 0.2. So this is the green line, okay? So when we plot this green line, why? Because it's this linear relationship. Okay, so if this green line, when you are diversifying with these two, A and B, so what happened is as you increase your risk standard deviation, right? Then your return will increase, right? So in this portfolio, then the investment doesn't help, right? Because you are just trading off the risk and the return. When you have higher risk, you have higher return, right? Because it's a positive straight line, right? Positive, perfect straight line. Okay? So that is the green line. So now I'm going to talk about the blue line. It's interesting, right? Blue line has 2 parts, right? So again, same formula. If the blue line representing rho equals -1. So if rho equals -1, the formula will becomes this. Okay. So again, this is just algebra, right? I did nothing fancy mathematically, right? It's just the pure algebra. You have learned this in probably junior high school, yeah. And then the standard, the variance equals the variance here because there's a square. When you are solving the standard deviation, because this is a negative, there are 2 possible outcomes. So one is the 0.55 WL minus 0.1 if this is positive. The other one is the opposite, 0.1 minus 0.55 WL, because standard deviation has to be positive, right? So depending on the number of WL, it could be either or, right? Either the 0.55 WL minus 0.1 or 0.1 minus 0.55 WL, okay? Okay, so, and my EP is the same, 0.05 WL plus 0.2. So I could have 2 potential equations, okay, in blue color, okay? Each equation representing a line, right? So this negative, so this is the a slope downward. So the bottom line, this bottom line here, this bottom equation representing this line, the bottom downward slope line. And the top equation here with a positive slope. So that's from here to here, right? So why rho equals -1 when they are negatively correlated? They have 2 equations. That's the reason, right? Okay, so that's interesting for this one. When you have 2 assets, they are going the opposite direction. You can actually help yourself to diversify the risk. Okay, how does it happen? See this, right? Okay, so if you only have B, right, you have a return of 0.2, but you are taking a risk of 0.1. But look at this, right? When you adding up the weight of L, right? So you go from U to L, right? So from U to L, you see the path. So when you keep adding the weight of L, so you get to this point, it's very interesting, right? Because your return is going up, your risk is going down, right? So when you are at U, when you only invested on the asset of B here, your risk is 0.1, your return is only 0.2. But if you keep adding your weight of L, you are able to get 0 risk. Did you see that? Standard deviation is 0, right? But your return is even higher. So this is the point. So if the sigma p is 0, your return is close to 0.21, I think. Yeah, so here is close to 0.21. Isn't that great? Right? By adding, because of you picked, let's say B or U, when you add a stock that is perfectly negatively correlated with your stock, okay, what it does is, when you keep adding it, what it does is, it reduces your standard deviation and increasing your return. So your portfolio's risk is lowered, at the same time your return is higher, right? Okay, so if you consider this is a minimum risk point, right? So this is two lines, right? There's a turning point here, pretty sharp turning point, because these are two lines on each side, right? So at this turning point, you have the minimum risk because the standard deviation is 0. And your return is also pretty good, right? Your return is more than 0.2, right? See how having two different eyesight that are perfectly negatively correlated dots to your portfolio, right? It reduces the risk, but doesn't affect your return, even increase your return. Okay, so anything between would be in this triangle. Okay, so we defined t low equals 1. That's the green line, right? And when low equals -1, so I have two blue line, right? So this three line forms a triangle, right? Forms a triangle. So when low equals anything between -1 and 1, so the curve, the graph will be between. So for example, if low is a 0, they are not correlated at all. You're gonna have this red line, okay? This red line. Okay? There's a curve here, okay? And the curve will be more until it becomes this sharp point. And the yellow line is low equals 0.7. Okay, so imagine how many lines there are when for different level of the low. Okay, so there are some terminologies for the portfolios. So feasible sites, right? What are the feasible sites? We also call it opportunity sites. So that's the curve comprises all of the possible portfolio combinations. Okay. So the feasible sites are the curve that comprise all of the possible combinations. What is the efficient site? Well, the efficient site will only include the efficient portfolio where the maximum return is achieved for a given level risk, or in the same the other side of the same coin is that the minimum risk is accepted for a given level of return. These are the two things of the same coin. Okay, two sides of things of the same coin. A minimum variance portfolio, where you could achieve a possible portfolio with the least amount of risk, right? When you have the minimum variance. Minimum variance means minimum standard deviation, right? That means the least amount of risk. Okay, so if you have this site, right? If you have this site, okay, and so this curve, depending on the weight, right? Depending on the weight of the, because this curve tells you already right away what is the low, right? This is the low between probably 0 to 1, right? So that tells you how this L and U, they are correlated, right? But the different points representing the different combinations, right? So in this set, at U, you have 100% of U. At the point of L, you have 1% L. So the different point representing the increasing weight of L, right? But you can see that this curve shows you that there is a minimum variance portfolio here. it's called the efficient frontier, right? At this point, that combination is an efficient portfolio. That is the efficient combination of the asset. So that portfolio will achieve the minimum variance, right? You can see that, right? That portfolio will achieve the minimum. So that's great, right? You get the least amount of risk, right, for that portfolio. Realized return are generally not equal to expected return. Expected return means you keep doing this for many years, right? Overall, you are expecting this is your return. But for any single year, right, the realized return are generally not equal to the expected return. There are the expected component. There's also the unexpected component, okay? The unexpected component can be either positive or negative. Sometimes we say black swan, right? Black swan, right? So that means it's unexpected, right? Unexpected. Over the time, the average of the unexpected is 0. Since we will not always you will not always receive good news surprising you, right? Sometimes it's the bad news, right? So, you know, the expected return could be positive or could be negative, right? Announcement of news contain an expected component and a surprise component, right? So the public information, companies making an announcement, there are news, right? Maybe CEO passed away suddenly, right? Those news may contain both expected and a surprised unexpected return. What really affects the stock price is the surprise component, because the expected component information has been analyzed, incorporated in the stock price already. So only when you have new information, the surprising information, it's gonna change the equation, and when everything is reanalyzed, the price will be changing, right? Efficient market, right? Efficient markets are the result of investors trading on unexpected portion of announcement, okay? So again, it's the unexpected component. So if the market is efficient, right, the investors should be able to incorporate the unexpected information into the price and change the stocks based on that price. Okay, if it's easier for the investors to trade on the surprises, the market is more efficient. Okay. Systematic risk. Okay. So risk factors can affect a large number of assets, right? So as known, also known as diversifiable risk or market risk. Okay. So for example, COVID happened, right? So COVID happened is going to affect a lot of the assets investment, right? COVID is going to affect many industries, right? Many, let's say airplane, right? The transportation industry, right? The restaurant industry, right? So if you purchase the stocks in those industries, right, all these assets will be affected negatively by COVID, right? So those will be considered as a systematic risk, right? This is also known as non-diversifiable risk, right? Market risk. So it doesn't matter how many stocks you purchased, right? Sometimes it's hard to diversify this kind of risk. Some other example would be GDP, right? If GDP is going up, then it's right. The GDP is going down. That would be a risk for everything in the market. Inflation, interest risk, right? So this is going to impact the whole market, right? You cannot diversify those risks. Unsystematic risk would be the risk affect only limited number of assets, right? So those will be very unique, specific, asset-specific risks, right? So what would be a risk for? Let me think. What would be a risk just for the? Let me think. unsystematic risk. So the example here given is the labor strikes, right? The labor shortage, those things for certain industries, right? You know, you can do business, but you don't have enough people working for you, right? So risk factors affect a limited number of assets, okay? Unsystematic risk. Boy, I don't have a clear brain today. Okay, so I'm gonna leave it like this. But the whole idea is, you know, these kind of six factors only strike certain industries, right? Not on the whole market, right? Yeah, yeah. Sorry. So return, the total return equals expected return plus unexpected return. And unexpected return has two components, systematic return plus unsystematic return. Okay. So the formula for the return would be total return equals expected return plus systematic return plus unsystematic return. Diversification, okay. Portfolio diversification is the investment in several different assets or sectors. So diversification doesn't mean you hold lots of assets in a portfolio. Even you hold like 50 stocks from the IT industry, you are not diversified. If you own 50 stocks across 20 different industries, you are diversified, right? Because the stocks in the same industries are often positively correlated, right? Right? Because they are in the same industry, anything affected one stock will also affect the other stock, right? So you have to try to diversify it across different industries. Okay. Take a look at this interesting information, right? If you randomly pick from the market one stock, the standard deviation, the risk is 49.24%. But that risk standard deviation can be reduced by increasing the amount of the stocks in the portfolio. When you have 100 stocks, that standard deviation has been reduced to be only 40% of the standard deviation of when you only have one asset, right? So that's quite impressive, right? That's quite impressive. The principle of the diversification, so diversification can substantially reduce the variabilities of return without an equivalent reduction in the expected returns. So the idea is when you diversified, you're going to reduce the volatility, the variance, right? But maybe at the same time, you also reduce the return, but the amount of the reduction in the variance is more significant compared to the reduction in the expected return. The reduction in risk arises because the worse than expected returns from one asset are offset by the better than expected returns from another, right? So one is doing bad, the other one is doing better, right? So on average, you still achieve your expected return, right? However, there's a minimum level of risk that cannot be diversified away. That is the systematic portion, right? Remember, we talked about when you do business, right? When you are on the market, there's a risk. You can never diversify. So take a look at this picture. After you add in 100 stocks in the portfolio, adding more will not help you because once you have been diversified, then you reach to this plateau, right? So the plateau representing the 19.2% representing the non-diversifiable risk, okay? Because of the market, you do business, you have reward, you take a risk, and you are taking that non-diversifiable risk. The risks that can be eliminated by combining assets into a portfolio, those are the risks of diversifiable risk and this non-systematic risk. Okay, so if you hold one asset and assets in the same industry, you are exposing to the risk that you can potentially diversify away. And the bad thing is, if you take that risk, too bad, the market will not compensate you for taking that risk, because those risks are unnecessary. You can just reduce that risk, eliminate that risk by, have a portfolio, right? So total risk equals systematic risk plus unsystematic risk. The standard deviation of the return is a measure of the total risk. So your total risk is measured by the standard deviation, but it has two components. One is the systematic risk, the other is unsystematic risk. For a well-diversified portfolio, the unsystematic risk is very small. It may not be zero, but it's very small. So consequently, the total risk for a well-diversified portfolio is essentially equivalent to the systematic risk. So there's a reward for bearing risk, high risk, high reward. But there's no reward for bearing risk unnecessarily. Okay? So, for example, when I'm driving the car, okay? What is the risk and what is the reward, right? So when I'm driving the car, the risk I'm taking is I may got into a car accident, car crash, and die, right? That's my risk. And what's my reward? Well, it can make my life easier, right? For people who are really afraid of being killed in a car accident, they will not want to bear that risk. But guess what? They can never enjoy the freedom of driving, the mobility, right? So there's a reward for bearing that risk, but there is not a reward for bearing the risk unnecessarily, right? So let's say you are driving, but not only you are driving at high speed, right? You are racing cars, right? So when you are driving, at a higher speed, you are taking more risk, okay? But guess what? That doesn't pay you, right? Actually, maybe hurt you. If you driving at a speed over the speed limit, your chances being killed is higher, okay? But at the same time, your reward is not higher, okay? Maybe you will be stopped by a cop, give you quite a significant ticket. You have to pay a lot of money, right? So there's no reward for bearing risk unnecessary, right? If you do investment, you don't do the diversification, you are taking that risk, too bad, right? That's the reason why you are learning from me. We are learning from this course, right? So the unexpected return on a risky asset depends only on the asset's systematic risk, since the unsystematic risk can be diversified away. So measuring the systematic risk. So how do we measure the systematic risk? We use beta coefficient. What does it tell us? When beta equals 1, that means my portfolio have the same risk as the overall market. When beta less than 1, that means I have less risk than the market. When beta greater than 1, I have more risk than the overall market. So in this picture, you can see the volatility for different beta. When beta equals 0, that means there's no risk. That means no volatility. It's a straight line, right? There's no uncertainty. It's always a constant number. It's so predictable. Every year is the same number. It's like my height, right? I have no risks of growing taller or shorter year by year, right? So my height is constant. So there's no risk. Beta equals 0, right? But if you are playing the swing, right? You're playing the swing. So you would swing like from the high to the middle to the low, right? if this, so think about the swing, right? If you don't swing, beta is 0, no risk. If you swing a little bit, low risk, right? If you swing wider, swing more risk, right? So therefore, the market beta equals 1. So the blue line representing the market risk, because the market are taking the risk, right? But when beta equals 1, see the volatility is higher, right? It's more volatile. When the fluctuation is greater, it's more volatile. It's more risk, right? So you can see the green line is more volatile, right? So it's like bigger swings, right, from the top to the low. The market is only like this fluctuation, and the green line is like right. So here are some of the beta coefficients for the selected company. You can see Scotiabank, that's less than the market. IGM Financial is 1.7 more. Ambridge 0.94, and Rogers Communication, this is very low, 0.33. Yeah. Okay, so in this situation, you have security C and K. You know the standard deviation, you know beta, right? My question for you is, which security has more total risk? Well, total risk is measured by standard deviation, right? Total risk has two components, systematic risk plus unsystematic risk. And what measures the total risk? Standard deviation. Which one has the more total risk? Well, the security with higher standard deviation, which is security K, 30%. Okay. Well, which security has more systematic risk? Well, systematic risk is measured by beta, right? So higher beta means higher systematic risk, right? So in this case, security C has higher beta, 1.25. So security C has a more systematic risk. Which security should have the higher expected return? Well, expected return, right? Think about this. Expected return is only is rewarded by taking systematic risk, right? So expected return is rewarded by taking systematic return, because non-systematic return is not rewarded. So the expected return is the result of taking systematic risk. So if the systematic risk beta is higher, your expected return will be higher. So that will be security C. Okay, examples. How to calculate the beta of a portfolio? Well, this is pretty straightforward. So you use the weight for each security multiplied by the security's beta. So you can calculate the weighted portfolio beta. Beta and the risk premium, right? If you remember, when we learned about the risk premium, we use the expected return minus risk-free rate, right? So difference between your expected return and the risk-free rate, that's your risk premium, okay? And we also know that the higher beta, the greater the risk premium, right? The higher beta, the greater of the risk premium. So can we define the relationship between the risk premium and the beta? The answer is yes, okay? So how do we do this? We are doing this, we are using the risk premium divided by the beta, okay? Okay, that's how we define that. So the reward to risk ratio, that's the return, right? Reward is the return, and the risk premium. To the risk ratio, the risk you are taking, that's the systematic risk, right? Necessary risk, and that's your beta. So your risk premium, so expected return minus interest-free rate. divided by beta. So that is the ratio, the reward to risk ratio. So that's the slope. So in the previous example, the reward to risk ratio is 7.5. What if an eyesight has a ratio of higher, as 8, more than 7.5? Well, that would be good, right? Because for taking the same level of risk, you have higher return, right? So the higher of the reward to risk ratio, the better. So think about this. The reward to risk ratio, the higher the better. For the same level of risk, if that ratio is higher, you have higher return. In equilibrium, all the assets and the portfolios must have the same reward to risk ratio, because it's a market, right? Because if there is a higher ratio, everyone pursue it, right? And then what happens is at the equilibrium, everyone will get a market risk reward ratio, right? So the security market line is the line that representing the market, right? So you use the expected market return minus the interest risk-free rate, RF. This is your market premium divided by your market beta. And the market beta is always 1, right? Remember, we define beta equals 1 for the market. So therefore, the slope, so the ERM minus RF, the market risk premium. So this can be written this way. So then, for the expected return of an asset can be written this way. So as equal to your risk-free rate, okay, plus so your market premium. Okay, this is market premium. If you are taking the risk as the market, beta equals 1, so then you are receiving the market rate. If you are taking more than market, you are receiving more premium, right? If you're taking beta is greater than 1, your expected return will be more than the market. So factors affecting expected return. First one, pure time value of money. So that will be the risk-free rate, right? So that will be the RF. Reward for bearing systematic risk. Okay, so that will be the market risk premium. So if you are taking systematic risk from the market, you get a premium. So that's the ERM minus EF, right? Minus RF. Amount of systematic risk you are taking. You take more, okay, your beta is larger, right? So that's this formula. So this one, I'm almost done with today's lecture. Just 2 more slides, I think. So this one, this is your expected return. This one is the time value, right? That's the risk-free rate. And this one is the market premium. This is because you're bearing the market systematic rate. And this one measures the amount of risk you're bearing, right? Is that more than 1, equal 1, or less than 1? Right? Okay. Okay, so that's it. Today is a little bit long, but I hope everything makes sense to you. Okay, that's it. Thank you.